derivatives is probably exactly what you would think. In fact, I might mess you up if I taught it. So I'm gonna say that f of x equals to the sine of x. And I want you to take the second derivative. What do you think the second derivative is?
Taking the first derivative and then taking the.
Yeah, that's all it is. So f prime of x is what?
One.
Bless you.
Whatever.
Cosine of x. So f double prime of x, which we use a 2 apostrophe system on that,
Is negative sine x.
is negative sine of x. So basically, a derivative is the rate of change, and a second derivative is the rate of change of the rate of change. Now, let's take that in context as far as a real life situation is concerned. So, in physics, there's something just called position, right?
Yep.
Position is where you are. Now, how would you measure the rate of change of position?
I took this last year. Y'all want it now.
Hmm? Okay, okay. Well, how would you, if I go from here to the back of my classroom, how would you go about measuring the rate of change of my position? Yeah, you would measure the distance from here to the back of the classroom, and then you would time how long it took for me to do that. Now, what is that called if I have a change in position with respect to time?
Velocity.
Velocity, yes.
Or speed.
So you can have the position function, which we will call s of t, and basically v of t, velocity, is the derivative of the position. V of t is the derivative of position. Now, a few things using physics terms. Using physics terms, you have a measurement of speed, and you have a measurement of velocity. And they're nearly the same thing except for one thing.
Direction.
Yes, velocity has an implied direction to it. So speed going up and speed coming down, the speeds would be the same, but the velocities would be different. My velocity as I go up is positive, and my velocity coming down is negative. So if you see something that says something's velocity was negative something, then that just means the direction that it was going. So it's called a vector quantity. This is, again, when y'all are talking this weekend with your friends, and you get to talking about, I know a couple of times I've had students gotten arguments about what velocity and speed were. Well, you know, you can say, hey, they're two different things, but not totally different. The negative sign with velocity just tells you your direction that you're going, where speed is always positive. So it's called a vector quantity because it has a magnitude, which is basically a quantity, and a direction. Magnitude and direction gives it the vector quantity, so that's what we call a vector. And also left and right. If you're moving to the right, then you are said to have a positive velocity. If you're moving to the left, you have a negative velocity. All right, and then the final one, how would I measure the rate of change of speed?
Rate of change of speed.
Or rate of change of velocity, sorry.
Okay,
Rate of change of velocity, I'm sorry. Yeah, it's acceleration. So acceleration is v prime of t. Well, guess what v prime of t would be? it would be S double prime of t.
Does the S stand for speed?
Position,
Position.
yes.
I don't think so.
You've got a lot of things in mathematics that correspond with P. They use S a lot of times. I've also seen position done as X of T. And if you're talking about just things moving vertically, this value will be sometimes H of T. But that's what we're dealing with there. My screen went blank. But I think it's still recording. Yes, it is still recording. Okay. So, any question there? Now, I'm going to give just a basic position equation. Okay, so I've got 4.9 t squared, negative 4.9 I should say, negative 4.9 t squared plus 28t plus 12. Now, what this is grouped with, this is associated right here with my acceleration due to gravity. And this is in terms of meters. So your units for acceleration in the metric system is meters per second squared, typically. Now, I mean, you could do meters per hour squared, but typically we're going to go with meters per second squared. And this equation right here is also known as the position formula for a free-falling object. And believe it or not, a free-falling object, once this leaves my hand, it is a free-falling object. Even though you're like, well, it's going up for a little bit. But it's still a free-falling object because a free-falling object is an object that the only force that's acting on it is gravity. So once it leaves my hand, there is no force that keeps pushing it up. It had the initial force behind it, but at the instant it leaves my hand, it starts slowing down. So we've got the gravity, this is your formula. Now, V of t is going to be the derivative of this. So it's negative 9.8 t plus 28. Now, a couple of things what some of these other terms mean in here. This 28 is known as the initial velocity. So I'm saying that this is going at 28 meters per second. So that's pretty fast. So that's its velocity. And this is its initial vertical position, typically. If we're not in a free-falling object, this could be a starting position along the x-axis. But this would be like me starting at 12 meters high. So I'm going up pretty high, basically. It's pretty close to what you would see on an Olympic diving board. That's 10 meters instead of 12 meters, but you would be starting off and throwing something up from about that height. Any question there? All right, so now, if I want to know the acceleration, A of t is, what would be the derivative of that negative 9.8 t plus 28?
Negative 9.8.
Which is negative 9.8. Now, the interesting thing about this is, what do we not have here? Well, we don't have that, but something else.
T?
T. There is not a t involved here. So what that's telling me is that the time does not affect the acceleration. Time does not affect acceleration in a free-falling object problem. So if I ask what the acceleration is when it's at the very top of its path, it's negative 9.8 meters per second squared. So, any questions about this? So I can give you a problem, and in that problem I can say, all right, and this work was actually gonna be on not the next coming test, but the following test, but there will be stuff about this higher order derivatives on your next test. But I could say, what is my height and position at 3 seconds? My height and velocity. I think I said that wrong. What is my height and velocity at 3 seconds? Now, sometimes you have to come up with this equation. Other times you are given it and you just plug in. Here we're basically given it. So I would say S of 3 is negative 4.9 times 3 squared plus 28 times 3 plus 12. Did someone do that in your head real quick?
This is my
Wait,
head.
put it in our head, actually.
I can. Please.
I want it done quicker than that, so do it in your calculator.
$140.1.
Okay, so the position is 140 point what? 1, and it would be meters. All right, what is the velocity at that period of time? Well, V of 3 would be negative 9.8 times 3 plus 28.
Negative 1.4.
Okay. Okay. So what that tells me is it is just, this isn't very fast. 1.4 meters per second is not very fast, comparatively speaking, with what you would get, especially the fact that we start off with a velocity of 28 meters per second. So what this is saying is it just passed its apex and it's starting on its way down. So the negative tells me it's in the downward direction. All right. Okay. Also, just one last thing, and then we'll go on from this. One other thing that's happening here is, notice when you take the velocity equation of the free-falling object, again, this is neglecting any kind of wind resistance. The initial height goes away. So basically what this is saying is the initial position does not matter for velocity. So someone could stand on the ground and throw this object up, and someone could stand on top of the roof and throw this object up. And if they had the same velocity leaving, then what you would see is they'd have the same velocity leaving. So whether the person started from the ground or started from, of course, no, you're not going to throw it up. Anyway, whether you're leaving, I'm sorry, let me back up. Whether you're throwing it from the roof or from the ground, your velocity at 3 seconds would be that value. So the initial height is not affected.